Okay, welcome back to The Explainer. Today, we're taking a pretty intense dive straight down the computational rabbit hole. We're going to start way up at the surface, right at those digital interfaces you and I use every single day, and we're going to descend rapidly down to the raw, deterministic, completely unyielding metal of GPU execution. If you've ever wanted to understand how messy human thought actually compiles into physical lightning, well, you're absolutely in the right place.
So, let me ask you, are we interacting with computers all wrong? I mean, really think about it. Every single day, we rely on these heavy, bloated, graphical user interfaces. You know the ones, GUIs with their rounded corners, soft drop shadows, endless nesting menus. But what if I told you that this pretty visual illusion is actually a massive dead end? By relying on these sluggish visual abstractions, we are severely limiting our ability to communicate with the machine at the true speed of thought.
There's this incredibly visceral quote from our source material that I love. It says, "We get the chimpanzee hitting buttons, but we chat with each other. We could be hitting buttons, but it isn't as good." It perfectly captures that almost animalistic, lever-pulling nature of graphical interfaces, right? Compare that to the profound, highly expressive power of human language. By forcing ourselves to just click shiny levers for a little digital reward, we're actually trading away the deep, continuous nuance of how we naturally communicate.
So here's our roadmap for this descent. We'll trace the GUI dead end across the semiotic bridge through deterministic typesetting and cellular automata, and take it all the way down to tiling the modern GPU for perfect ALU fidelity. It's a very deliberate, structured macro-to-micro journey.
Section 1. The GUI dead end. Look, there's a fundamental clash here between the fluidity of your mind and the rigid reality of computer hardware. On one side, we have our human brains, what researchers like to call OS alpha. We're fuzzy, we're highly associative, continuous, and probabilistic. We naturally deal in context and feeling. But on the other side, we have the arithmetic logic unit, the ALU. This is the literal calculator inside the microchip, and it is totally cold, rigid, driven entirely by exact clocked voltages, and it is strictly deterministic. There is zero meaning down there. The machine is utterly blind to our intentions. It literally only understands physical resistance and electricity.
So, how do we cross that gap? Section 2. The semiotic bridge. To bridge these two completely alien worlds, we use the semiotic bridge. This is the exact mathematical text layer that safely compiles all your messy, boundless human imagination into strictly predictable electrical impulses. You see, text isn't just for humans writing emails to each other. Strictly formatted text is the ultimate universal deterministic interface. It's actually the absolute only way to map our nonlinear thoughts directly onto a physical silicon substrate without a catastrophic misinterpretation.
And this brings us right to the mathematical purity of the command line interface, the CLI. Think of the CLI as an evenly spaced, chopsticks-tiled matrix of text cells. It's completely streamlined. By rendering just a single character on this exact discrete grid, we entirely bypass all the bloat and latency of those graphical interfaces we talked about. We are trading fragile, pixelated guesswork for a 100% exact, lossless fidelity log. The text grid is, essentially, the purest form of digital truth.
But this discrete grid didn't just appear out of thin air. Section 3. Deterministic typesetting.
Way back in the 17th century, geniuses like Descartes and Fermat completely shattered classical limits by forcing continuous physical shapes onto an abstract algebraic grid. They literally proved we could capture reality in discrete symbols. Fast forward to the digital age, and computer scientists like Donald Knuth did the exact same thing with language. Knuth's deterministic typesetting systems, like LaTeX, give an author absolute mathematical control over the final printed page. There's zero ambiguity. It is the perfect, lockdown translation of continuous human ideas into a discrete grid.
But here's the tricky part. How do you keep a discrete system running continuously without it just crashing? Section 4. Cellular automata and geometry.
Think about Conway's game of life. It's a cellular automata where really simple, discrete grid rules create infinite, continuous complexity without ever crashing. Now, traditional systems often treat data as static, which inevitably leads to fatal stack overflows when recursive logic loops out of control. But modern architectural concepts use what's known as Pythagorean scaling. By applying a continuous geometric transition, specifically using a self-similar infinite tiling model with a 1/3 scale parameter, we can actually power cellular automata that literally never reach a terminal state. It seamlessly bridges that continuous flow of information with the strict boundaries of geometric tiles.
So the crucial thing to visualize here is this macro to micro funnel of formalization. Step 1, we start with messy human intent. Step 2, we squeeze it into that rigid CLI chopsticks grid. Step 3, we lower that text into a geometric tile intermediate representation. And finally, step 4, pure ALU execution. At every single stop down this ladder, we are deliberately trading our expressive human freedom for strict mathematical certainty.
So, what actually happens at the absolute bottom of that funnel? Section 5. Tiling the modern GPU.
To achieve the massive AI performance we see today, we rely on tools like Qtile. This is a Python-based domain-specific language from NVIDIA, and it is a total paradigm shift. Instead of manually telling thousands of individual microthreads what to do, developers map abstract, multidimensional array fragments, which are literally called tiles, directly to the GPU's tensor cores. Frameworks like PyTorch use this to force all that complex, continuous, probabilistic math of modern AI into extremely rigid, deterministic tile semantics.
To put that into perspective, the legacy SIMT model, single instruction multiple threads, required massive error-prone manual overhead just to manage thousands of individual thread indices. It was a headache. The Qtile block model abandons that completely. Instead, it uses the beautiful, mathematically pure matrix execution of abstract logical tiles, where the compiler automatically handles the physical mapping. We are quite literally taking that chopsticks-tiled matrix from the command line interface and projecting it directly onto the physical silicon of the microchip.
Which brings us to the most critical layer of all, Section 6, perfect ALU fidelity. At this level, we absolutely have to differentiate between two very different types of machine logic. First, you have the floating point unit, or what we can call the FPU gambler. It's incredibly fast, sure, but it's lossy. It uses approximations, rounding off decimals to run continuous vector spaces for things like large language models. And frankly, it's completely unaccountable. On the exact opposite side, you have the ALU surveyor. It performs exact, verified integer arithmetic. 1 + 1 is exactly 2 every single time on every single machine on Earth. It provides perfect determinism and universally verified truth.
And this divide is exactly why AI struggles so much with verifiable facts. AI relies on tokenization, like byte parent coding, which literally chops continuous numbers into totally arbitrary non-decimal chunks. The logic just completely breaks down. But by moving away from spatial approximation and using strict integer geometric rigor, eliminating what our sources call the trig wall, we don't just gain accuracy. We actually hit a staggering hardware energy floor of just 0.05 picojoules per operation. To get that insane efficiency and undeniable truth, we have to use our text-based divine script to intercept the probabilistic AI and enforce verifiable execution.
So here is the absolute massive takeaway you need from today. If we blindly rely on probabilistic AI systems, if we just let the FPU gambler run the show, and we abandon our deterministic text interface, we are quite literally abandoning our control over the physics of the machine. We absolutely need that rigid, tiled textural anchor to keep the digital world honest.
So I want to leave you with this. As our computing interfaces rapidly evolve, as AI tries its hardest to replace the command line and that semiotic bridge between human thought and hardware execution begins to shrink, if we stop writing the deterministic text, who controls the physics? Think about it. Thank you so much for joining me on this deep dive into the matrix, and I'll catch you on the next explainer.